going to do a couple examples here to explain how to do problems on page 297, 30 through 35. And I got it all set up here for you. This is going to be awesome. Finding the 6 trig functions for an angle in standard position if the point with the given coordinates lie on its terminal side. And I have the point here. So your homework is going to just be a point, and you're going to have to figure that out. This is the coordinates of a point. So let's plot this point. Well, that's going to be over 4. Make sure I'm on the right thing. There we go. It's going to be over 4, 2, 3, 4, somewhere like that. And up 5. 1, 2, 3, 4, 5. So this point is going to be right there. Right here. We'll get a little fancier color. There we go. And we're going to connect that to the origin because this is one of those spinning angles. That's what the whole terminal side is. It starts in standard position. That means I'm going to erase this, so don't write this. It starts here and then starts here and spins this way. That's what it means to start in standard position and be a terminal side. Okay, so what you have to do is connect this, just like the other day, from the tip of the arrowhead straight down, like that, making a right angle, and this is going to be your reference angle in question. But this time, this hypotenuse isn't 1. It's not 1 this time, because this is, how long is this right here? That's going to be 4. We're going to call that -4 because it is, it's -4 units from the origin, and it's up 5, so this is 5. Now, if I list all 6 trig functions out here real fast, sine, cosine, tangent, cosecant, secant, cotangent. Can you solve for all these things? Well, you have to get the length of the hypotenuse first. So you're going to have to do a little Pythagorean theorem on here. So check this out. This is like a squared and b squared, and this would be your c or whatever. So it'd be -4 squared plus 5 squared equals c squared. And that, of course, -4 times 4 is 16 plus 25 equals c squared. We're just plowing through this. That's 41 equals c squared. So the square root of c squared would equal c. So this hypotenuse length, this c, equals the square root of 41. So this is, we'll label this, radical 41. All right, cool. To get the sine, that's, of course, from this angle right here. From that angle, that's opposite over hypotenuse. So that'd be 5 over radical 41. And now at this point you should start being able to do this in your head, I think. I really do. So we multiply the bottoms. We've done this 100 times. And that would be 5 radical 41 over positive 41. And also, something else to note. The hypotenuse is always going to be positive on these. And the reason why is because when you square negative side lengths, it gives you a positive answer because it's -4 times -4. So this is going to be your answer. Okay, the cosine, let's just keep going here. The cosine is going to be adjacent over hypotenuse, so that's -4 over radical 41. And we have to do the same thing. Multiply it by the square root of 41. Again, if you can do that in your head, go for it at this point. But that would be 41, final answer. Final answer. I'm going to put 2 little red circles around these, and I'll come back to it. I want you to start thinking about why I'm doing that. Okay? Tangent. Opposite over adjacent. That's 5 over -4. Make sure you're paying attention to the negative signs. 5 over -4. All right. Now's where the red circles come in. Because if I'm doing the cosecant, which is the reciprocal of the sine, instead of flipping the blue circle, flip the red circle. That's that's kind of a payback for writing that down initially. That's why you should always do that. So this is radical 41 fifths. This would be radical 41 over negative 4. Okay, I'm just flipping red circles over. And the cotangent would be negative 4 fifths, final answer. And that's what you do on those problems. 6 trig functions. So that's that. All right, now I'm going to have you guys try one. So I'm going to set this up, and I want you to, I'm actually going to pause this, and I want you to try to get all 6 trig functions based on this. And if you're like, I'm not sure where to start, you would plot this point, negative 4, negative 3. So that would go over 4, down 3, to that point right there. And then you take that, connect it to the origin, and then take the tip of this thing where the point is, connect it to the x-axis. Always to the x-axis. Never connect it to the y-axis. Never. Label your points. So this side here would be negative 4. This side here would be negative 3. So we're getting the sides. I'll make that green right there. All right, and I'm going to pause it, and I want you to try to figure this out. Okay, I'll be right back. All right, now let's say you're doing this problem, and you're still a little bit shaky on SOHCAHTOA. Just it's SOHCAHTOA. Come over here and go SOHCAHTOA. Just like that. Learn to spell it, write it, and you won't have to keep looking back and stuff like that. So this is 5, and I'm going to skip that. That's a 3, 4, 5 triangle. It's 9 plus 16. Square root of 25 is 5. Boom, done. Now, the sine would be from this angle right here. This is your angle here. That's angle theta. That's going to be opposite over hypotenuse. So that's negative 3 fifths. The cosine would be adjacent over hypotenuse. That's negative 4 fifths. The tangent would be opposite over adjacent, which is negative 3 over negative 4, which is just 3/4. So we'll circle our correct answers. And then for these, we just invert them. So this is negative 5/3, negative 5/4, and 4/3. All right, so that's basically it. And that's how you do the problems for tonight, 30 through 35. Have a good one.